So you've been asked to find the slope of the tangent line, which really means dy dx. And so the only way to find the slope is to take the derivative of what you see here with respect to x. So before we jump into it, I want to remind us of a couple things. This is a product with two terms p and q, and when I differentiate y cubed with respect to x, the 3 will come down and we'll have 3y squared. But since we're taking the derivative of y with respect to x, we have a dy dx term. And so here this first one is p prime q plus q prime p. Well, the derivative of the p term, the 3x, is just 3 times y. Plus, when you take the derivative of y, you get dy dx times the original p is 3x, plus the one that we've already done, 3y squared dy dx, and all of this equals 0 because the derivative of any constant is 0. In the problem, we were given an x of 1 and a y of 1, so we'll plug those in. This becomes 3 times 1 plus 3 times 1 times dy dx, that's this term, plus 3 times 1 squared dy dx, and all of this equals 0. So we can collect some like terms. 3 plus 3 and 3 makes 6 dy dx, and all of this equals 0. Subtracting 3 from both sides gets 6 dy dx equals negative 3. Dividing by 6 gets an answer of negative 1/2. If you knew what the derivative looked like, you could say that this is going to be a max and this is going to be a min because of how the derivative is changing sign. So that's how we start. We start by taking the derivative, and we get, bring the 3 down, 4x squared minus 6x plus 0. Now we want to see when it equals 0, so we'll set it equal to 0. We'll factor out a 2x and get 2x minus 3 equals 0. That means my zeros are 0 and 3 over 2 when I solve this equal to 0. So just like the sketch that I drew, now I can clean it up and change it for the new derivative that I have. 0 is at 0, and 3 halves, if this is 2 and that's 1, is 1/2. Now this is a positive leading coefficient and a quadratic derivative, so I know my derivative is shaped like this. And so I wanted a minimum. I want my derivative to change from negative to positive. So 3 halves is the local minimum. If they'd been asked for a maximum, then the answer would have been 0.